Hi everyone! So there are so many different soil sensors available on the market. Yet do you ever wonder why none of the leading smart irrigation controllers actually include one? Instead, they rely solely on weather forecasts to guess your soil moisture. Well, the truth is, most of the soil sensors out there just aren't reliable enough in the long run. So in today's video, I'm excited to give you an inside look at our patented soil sensor technology and show you exactly what makes it so incredibly accurate compared to anything else on the market. Alright, so let's tackle the boring physics stuff first. The agricultural industry and researchers have been deep diving into soil sensor technologies for many decades. The bottom line is that FDR-based capacitive sensors are currently considered the gold standard for accurately measuring soil moisture. The way this technology works is actually quite similar to the touch screens on your smartphones. Your phone screen detects the capacitance, essentially the moisture content of whatever it's in contact with. Since human skin is about 65% water, while most of the other materials are significantly drier, your phone can easily distinguish the difference between a finger tap and, say, your clothes rubbing against it in your pocket. This is also why those thick winter gloves prevent your touchscreen from working. So if this technology is so well established thanks to its use in our phones, why is accurately sensing soil moisture such a challenge? And more importantly, what has GeoDrops done to overcome these hurdles? So the biggest issue with soil sensors is ensuring consistent, full contact with the soil. If the sensor loses even partial contact, it can mistakenly report that your soil is significantly drier than it actually is. And surprisingly, this loss of contact is a pretty regular occurrence, about once every 2 weeks. This can happen because of 1. The soil expanding and contracting with daily temperature fluctuations, 2. Natural movement of insects within the soil, or even 3. Small animals just having a little bit of fun in your garden, shaking the soil ever so slightly over time. Now, if your sensor randomly thinks your soil is dry every 2 weeks simply because of poor contact, it's obviously not going to be very reliable. You'll get false readings indicating dry soil when still plenty wet, leading to overwatering, root rot, killing your precious plants, and a lot of wasted water. To tackle this fundamental contact problem, we dedicated over 9 months to a complete sensor redesign. We finally perfected our solution and filed for a patent in early 2023. Modern high-end soil sensors determine soil moisture by measuring the soil capacitance from a single sensor probe. For GeoDrops, we took a completely different approach and invented the world's first soil capacitive displacement sensing system using 2 separate sensor probes. This offers 2 key advantages. First, while other soil sensors essentially measure the 2D surface moisture using tiny sensor traces on a single probe, GeoDrops measures the 3D body moisture of the soil between its 2 probes. This fundamentally increases the stability and reliability of the moisture readings. Second, the physical design of having 2 sensor probes actively sandwiching the soil in between them dramatically reduces the likelihood of the soil losing good contact with the sensors. To push the accuracy even further, we engineered another unique feature into the GeoDrop sensor hardware, a fully fail-safe redundant array. If you're familiar with high-end computer systems, this is similar to a RAID array for storage or ECC memory, technologies typically found in enterprise-grade equipment. To the best of our knowledge, no other soil sensor on the market has anything close to what we're doing. So while the GeoDrops app might show you 2 or 3 distinct soil depth readings, the sensor actually contains 4 overlapping sensor arrays. This N+1 redundant design empowers the GeoDrops Cloud AI to achieve 2 critical things. First, if there are small, localized instances of loose soil contact, this redundant sensor layout allows GeoDrops to compensate and continue providing accurate readings. Second, even when the soil is perfectly stable and in full contact, this design extends the soil sensing coverage, leading to an even more stable and reliable moisture measurement overall. Finally, I want to share some tips about sensor calibration. The GeoDrops app shows the percentage moisture tailored specifically to your exact soil property. If you ever feel the soil moisture readings are inaccurate, for example if they remain at 100% for an extended period or never reach 100% even after thorough watering, then please remember to manually perform another deep water recalibration. This may be useful even if you haven't moved your soil sensor for months, because your soil properties, such as its density, can slowly drift over time, even after just a few months. Oh, and one more thing. If you have relocated or reinstalled your GeoDrops droplet sensor at a new location, we highly recommend waiting at least a few days before performing your first deep water calibration. This ensures that the soil has fully settled and is relatively compact, preventing significant changes in soil properties after calibration. So, we hope you found this video useful. Thanks for watching, and see you next time.
I'm a flower farmer in Central Oregon. I grow a lot of different types of flowers. I also grow lots of vegetables as well. Well, I have tried a lot of different sensors, and we have extremely sandy soil, and so the sensors never really got seeded properly, and so they just would not be able to give me any information. I would end up just putting them aside and not using them anymore. But GeoDrops has actually done extremely well in my sandy soil, and it keeps a really good contact. I haven't really had any issues with it. Oh, it's been really interesting to watch. I'm a total data nerd. I started doing something called pulse watering last season, and it was really helpful to have the GeoDrops be so precise about the watering, and I could really pinpoint exactly when I started pulse watering, and it gave me extremely detailed information about my moisture levels in both the deep root zone and up in my shallow zone. And it made such a difference with how I'm actually controlling my irrigation in my flower field. So it's really been amazing to see the progress of just all the information that, I'm a commercial farmer, so I need really good, precise information, and GeoDrops is right there for me.